Hello, and welcome back to this video series on proofs. Today, I'm going to explain what a mathematical proof is and give some simple examples. I'm going to start with a couple of important definitions before I tell you what a proof is. Recall from the last video that a statement is a sentence that is either true or false. So a statement can be something like, all elephants are mammals, or all bananas are pink. As long as it has a truth value of being either true or false, it is a statement. I'm also going to introduce a new definition, the definition of an inferential argument. So an inferential argument is a line of reasoning which draws logical conclusions from statements. So for example, I might tell you the statement again, all elephants are mammals. From here, you could logically conclude that elephants are a type of animal, even if you've never seen one before or don't know what they are, because we know if all elephants are mammals and all mammals are animals, then it's only logical to conclude that elephants are a type of animal. Wikipedia gives a nice, succinct definition of what a mathematical proof is, so I'm going to use that one. A mathematical proof is an inferential argument for a mathematical statement, showing that the stated assumptions logically guarantee the conclusion. So in other words, to write a mathematical proof, we take statements and using a series of logical steps, we draw conclusions, and eventually those conclusions lead to showing that a statement that we are trying to prove is actually true. As I said earlier, proofs use statements and logic, so it's important to know which statements we can begin with when we're doing a proof. First, it is always okay to use axioms. If you don't recall what an axiom is, it's something that is self-evidently true, and you can also check out the previous video if you want a more thorough review of axioms. You will also rely heavily on definitions, because definitions are statements. They're statements describing what different mathematical objects are. And if you're taking a math class, you can generally use any statements previously proven or stated in the class, unless your instructor tells you otherwise. And last, you can also use anything that's generally considered common knowledge at your level. So, for example, if you're in a university level math class, you can usually use facts like the interior angles of a triangle add up to 180 degrees without proving it. Here's an example of a short proof. I know this is a fact that all of you already know, but I'm doing it to point out some structural things about proofs. The statement we want to prove is the sum of two six-sided dice rolls is less than or equal to 12. Whenever you write a proof, you start it with the word proof, and you end it with either an empty box like I did here, or sometimes people will use the letters QED, which is an abbreviation for something in Latin. Either one is fine. You just put these around your proof at the beginning and end so that it shows very clearly where the proof begins and where the proof ends. Proofs are written using full sentences. We start this one with a statement, which is considered common knowledge. A six-sided die has the numbers 1 through 6 on its sides. Now, we just add the values of the rolls together, but in a proof, we must describe what we are doing very precisely. So we assign variables, m and n, to be the values of the rolls. We then add them together, and since each has a value of at most 6, we can conclude that their sum is less than or equal to 12. That's all for today. Thank you for watching, and I'll see you in the next video. That's all I'm learning. Hope that we can make a turn and start reversing.